volume, and then we'll talk about surface area afterwards. But the first thing we need to do is go through and identify what a prism is, because this is something when I asked yesterday, some people thought they understood what a prism was until that was challenged a little bit. So what do we think a prism is? Thanks, Harry. What do you think a prism is?
3D shape.
A 3D shape. Very good. I like that. So it's three-dimensional. What else is it? Might try the other way actually.
Not 2D.
It's not 2D. Very good, Harry. Wonderful. Insightful. What makes something a prism and what is not a prism? I'm going to run through some shapes and I'm going to ask you whether they're prisms or not. And you're just going to raise your hand if you think it's a prism. Who thinks that this tissue box here is a prism? Who thinks that's a prism? Good. Okay. Who thinks the Toblerone chocolate that you get? Just have a think about the Toblerone chocolate if you're not aware of what that is. It's like a triangle. It's long. Who thinks that's a prism? Okay. Who thinks that a book, this book here, is a prism? Is that a prism? Providing it was a perfectly even book. Who thinks this calendar, I don't know this calendar, this, so this is why I do numbers, calendar. Who thinks this candle is a prism or a form of a prism? Who thinks a pyramid is a form of a prism? Who thinks a cone is a form of a prism? Who thinks a dice is a form of a prism? Alright, two of those weren't prisms. Two of those weren't prisms. Who thinks they know which two? People, give me one of them.
Is the dice one of them?
The dice is not one of them. The dice, providing it's a perfectly square dice, you know sometimes they're rounded on the end, is not. That's a cube, which is a prism still, just a square prism.
The cone and the pyramid?
The cone and the pyramid, he's correct. So every other shape was a prism except for the cone and the pyramid. I'm going to draw these and see if we can see why that's the case. And I've taken a big risk drawing these. What shape's that? Well done to me, I've drawn that very effectively. What shape's that? Cylinder, poorly drawn cylinder, correct? One of those is a prism, one of those is not. I gave you the tissue box as an example. That's a prism, correct? And I said the cone was not. So tell me, what is the difference between the top shapes and the bottom shapes? Riley.
With the end, they're consistent, the bottom one.
So you said the word consistent. I like that word. Is something consistent and the ends?
Is it the parallel lines?
There are sets of parallel lines. Very good. That's very good. With the cylinder, it's not really a line, but you're right, on that it looks parallel. That's a good observation.
They have two identical lines.
Very good, they've got two identical faces. So this is what makes a prism a prism. So it's got a consistent cross-section. I'm just going to put cross-sectional area. And what that means in your language, who's seen how we slice ham? Who's seen the machine that slices ham? I'll give you a brief summary. You've got whatever you're slicing being pushed into this thing and it just goes slice, slice, slice on a rotational device there. A prism, if you slice it, every slice should be the same area. If I was to slice that pyramid, would I get that? So if I'm looking at my pyramid again, if I'm slicing up here, would you want the first or the last slice? Why do you want the last slice? bigger, okay? What about with my cylinder? Does it matter whether you get the first or the last slice? They're all the same size, correct? So a prism holds, and we call this, that face, that's the cross section. So anywhere through that shape you should find the same area, regardless of whether you slice it there, bottom or top. And that's what makes a prism. And that's important, but we're not going to talk about why that's important yet. We're going to talk about these two concepts, and then we'll go with talking about why cross-sectional areas are important. So, what is surface area? I want to talk about surface area. What is surface area?
The amount of space on the surface.
I've left a word out, or maybe not a word. Maybe a letter and a number. Square surface. Close. The amount of two-dimensional space on a shape. Cool? Should go back to my red pen. Very good, Jerry. I left out the word surface there. You were right to say that. Why did I not use the word surface when I just described that then?
Surface area.
Yeah, it's called surface area. I don't want to use the defining word in the definition. But you're right. It's on the outside of the shape. So the amount of two-dimensional space outside of our shape. When we talk about nets later on, a net is an example of a surface area. So is the outside of the shape. What's volume? Because we've all heard of volume, we know what volume is, but sometimes defining these terms is very difficult. Lockie, what do you reckon volume is?
How much something can hold.
Very good. I've left a word out. Yeah, 3D shape. I'm just going to put it in year 3 term. How much stuff something can hold. If you were to have something at maximum capacity, you just keep stuffing stuff in, that's how much it can hold. It is, as Coop just said, 3-dimensional space inside an object.